On the second part of page 5 at the bottom where it says practice writing functions, if you will go ahead and pause in just a few minutes so that you can write all these. You may not be able to read my handwriting, so you may have to unpause a couple of times, but if you can, then you can go ahead and pause. I'm just going to read through this, okay? So for the first parent function, we've got absolute value of x. Number 2, square root of x. Number 3, 1 over x. Number 4, 3 to the x. This is your exponential function. I can choose my base to be whatever I want, as long as it's positive and not 1. So I could have chosen 1/2 to the x, 5 to the x, and so forth. This is just your exponential function. And then finally, number 5 is your log function. This has a base of 10 even though you don't see it. So same thing with the base of a log as that of an exponential. You just have to make sure that it's not 1 and it is a positive number. Alright, so the transformations for each of these, you'll write these down as well. So the directions itself say, given a parent function and the indicated transformations, write the transform function in 2 different ways. First, you're going to write it with using function notation. That's going to be with your f of x involved. And then number 2 is going to be using the parent function. That's going to be either with the absolute value function involved, the square root, and so forth. We are going to use Desmos to check these as well to make sure we get the same answer. So for number 1, the transformations that we want are going to be right 7, reflect over x. Number 2, down 3, reflect over y. Number 3, left 5, down 2, reflect over x. Number 4, reflect over y, right 4, up 2. And number 5, reflect over y, left 1, and down 6. And so let's go back to number 1. We want to rewrite this f of x function in function notation so that it goes right 7 and reflects over x. So remember that when you want to make it go right or left, you're going to make it the number be inside with the x. So in this case, the number 7 is going to go in parentheses exactly where that x is. In order to make it go right, I'm going to do opposite of what I think. I'm going to put a minus. And then I'm going to put my f, which is the answer, name of my parent function. I'm going to put it simply on the outside. I also want to reflect this over the x-axis. In order to do that, my negative from your lesson that you did on your own on reflections, it's going to be negative on the outside here in front of the f. Okay, this should be my final answer for my g of x notation and function notation. We're now going to do g of x a second time, and we're going to do it using the parent function instead this time. So same thing with the parent function. This is going to be absolute value of x. But that minus 7 needs to be on the inside where that x is. So I'm going to put the minus 7 on the inside. And I'm simply going to put a negative on the outside. Okay? So this should be correct. We're going to use Desmos just to verify. So we'll go back into Desmos again. We'll type in our parent function, which in this case we said was absolute value of x. Okay? And then in the second line, I want to put in that g of x that I had using function notations. G of x is equal to, I had a negative on the outside, then fx minus 7. So we would just want to verify, first of all, did it go become a reflection over the x-axis? Certainly it did. It was going up, now it's going down. And then as you can see, it truly did move the vertex from 0, 0 all the way to 7, 0. So it did make it go right 7 units. So I know I've got the right answer. In the third line, I'm going to verify that that answer is also correct. So I'm going to put a negative, g of x, I guess I should say. G of x is equal to, in this case, negative, and then absolute value, and then we're going to put that x minus 7 on the inside as well. Okay, so you'll notice that if I turn this on and off, that green function and that purple function are going to land on the exact same spot, so I know I have number 1 correct. Okay, so now let's move on to number 2. In number 2, we want this to go down 3 and reflect over the y. In order to make it go down 3, we learned that for my parent function, the reflection of the down 3 is going to be like my plus d. It needs to go on the outside, but because it's going down, I'm going to put a minus there instead. So f of x minus 3 so far. And then to reflect over the y, I need to make all of my x's negative, so I'm going to put a negative in front of that x. Okay, my g of x is going to have a square root function in it. In order to write this without the f of x notation, I'm going to put the negative x on the outside, and then the minus 3 on the I think I meant to say inside. Put the minus x on the inside of the square root and then the minus 3 on the outside. You can go ahead and check this in Desmos for yourself. Make sure that you got it right. I'm not going to check it in this video, but you can go ahead and check it and make sure. All right, and number 3. So I'm going to start with my f. Inside my parentheses, I want this to go left 5 units, so I know that it's going to have an x and a 5. But in order to make it go left, I need a plus symbol because it's opposite of what I think. To make it go down 2, I'm going to take the minus 2 and put it on the outside of the parenthesis. And in order to reflect over the x, that means I need to take the whole function on the outside and make it negative so that all the y values become their opposites. Okay, I'm going to come over here on the right and I'm going to do this same exact thing but without the f of x notation now. This one's going to be a little bit trickier. So when I start this, I'm still going to start with my parent function 1 over x. Because of the moving left 5 at the bottom, you have to have that 5 down there with the x's. And then because it's moving left, I'm going to put a plus in front. So far I have 1 over x plus 5 to make it move left 5. To make it move down 2 on the outside of this, on the outside of this fraction, I'm going to put a minus 2. And then in order to reflect over the x, I'm going to take a negative on the outside of this whole fraction here. I'm going to put a negative out in front of it as well. And so there's my answer. Again, you can check both of these in Desmos, and I would highly suggest you do so to make sure these are correct. Alright, you may as well go ahead and put a star on these two. These are going to be like your stars at the top of this page where it's become a little bit tricky. And that'll be on page, number 5 as well. Both of these are going to be a little bit tricky. The reason I know that is because I'm combining a reflection over y with a right 4. And so we talked about when you combine reflections with shifting it right or left, you're going to end up having an extra step that you have to be careful of. Okay, so the first thing I want to do in order to make it reflect over y, because this is my parent function f, on the inside I'm going to make my x negative. That'll make me reflect over the y. In order to make it go right 4, I have to be very careful. I need to put another parentheses right after where that negative is, and in order to make it go right, I'm going to put minus 4. So now I have a parenthesis within a parenthesis. If you prefer, you do not have to write it this way. If you want to go ahead and distribute that negative out and make that negative x plus 4, you are more than welcome to do that. That's completely up to you. If you do it this way, then you only have one set of parentheses. I still need to make this go up 2, so I'm going to put a plus 2 here on the outside, which is the same thing as on this one if I wanted to make it go up 2. So this would be the notation for my 3 to the x, but using my f function notation. If I want to do the same thing, but without using this f here, using 3 to the x, the actual parent function, I'm going to start with 3. This time I'm going to start with the x minus 4, my moving it right 4. Because my x is in the exponent, I have to make sure that my minus 4 also is in the exponent. Okay. In order to make it go up 2 on the outside of this whole thing, not in the exponent spot, but as a bigger number, I'm going to put plus 2. And then in order to make it reflect over the y-axis, if I just simply put a negative here in front of the x, that is actually going to make it wrong. This is going to make it move to the left 4 units, as we saw in an earlier example. So what I need to do is I need to put a parenthesis around the x minus 4 to ensure that this is truly going to go to the right 4 units. If you prefer, you are more than welcome to write this as negative x plus 4, and you'll end up with the same graph. Okay? And then I'm not going to check this one, but I will check number 5. So you're more than welcome to pause the video now and go ahead and check that in Desmos. I am on my last one now. So log function, I'm going to start with my f of x. So I know I'm going to have f of x for my function notation. I want it to go left 1, so inside the parentheses I'm going to put x plus 1. But because I'm combining a reflection over y with a shifting left and right, I need to put an extra set of parentheses here, and I need to put a negative out in front of the x plus 1, but after the f. So you can either go ahead and distribute that and write this as f of negative x minus 1 in parentheses, or you can leave it the way that I have it. Either way is fine. And then to make it move down 6, I'm going to put minus 6 minus 6. Either of these notations will work. It doesn't matter which one you choose. Okay. To get rid of this f so that I don't have this function notation, so that I'm using the parent function this time, I'm going to start with my log function. Same thing. I'm going to start with my left 1. So inside parentheses, I'm going to put x plus 1 in order to make that go left 1. To make it go down 6 on the outside, I'm going to put a minus 6. And then back to that reflection over y. I've got two options. If I simply put a negative here, that is incorrect. My answer is now wrong. So I'm going to put a parentheses right after that negative. And so here is one of my possibilities. Or if you want to go ahead and distribute that negative, you're more than welcome to. You'll have one set of parentheses instead, and you'll have negative x minus 1 inside those parentheses. Okay, so it's very important that when you're combining your reflections with your moving it left and right, that you either put an extra set of parentheses with the negative on the outside, or you go ahead and distribute that negative using the distributive property. Okay, I will check number 5. So let's go in Desmos for this one. We're going to type in the parent function f of x, which in this case is log x. There it is. And then I'm going to type in g of x, which in this case is equal to f of negative parenthesis x plus 1 parenthesis. So if we look at this so far, you can tell that this really truly did reflect over the y-axis like I want. It also did go left 1. If you don't believe me, take out the plus 1 part. That's just a reflection over the y-axis so far. Put in your plus 1 now, and it truly does go left 1 unit. Then to make it go down 6, we'll put my minus 6, and then there it is, my last transformation. Okay, I'm not going to put the 1 in with the distributive part of this where it says negative x minus 1. You'll get the same thing. I am going to put in the other one, however, with the log in there instead. So I'm going to do the one with the distribution. Already done those. We have a log function, and it says parenthesis negative x minus 1, and then on the outside minus 6. You'll notice that even if I distribute it with a negative x minus 1 as opposed to the negative parenthesis x plus 1, I end up with the same exact answer in the same graph. Okay, so please be very careful when you're putting those two transformations together, the right, left, and a reflection. You have to be very careful and put an extra set of parentheses with a negative on the outside in order to make that happen correctly. Okay, and that's it for this